Good morning all. Today we're going to seal the positive high voltage module with ML Solar cell guard. This right here that I'm opening now is part A. We're going to mix part A with part B to make the sealant. Here is the part B component. ML Solar cell guard. Here's ML Solar cell guard, the B part. We're going to pour both the A part and the B part in this cup. After we get both the A part and the B part poured into the cup, we'll mix it all together and then pour it into the kit box that contains our high voltage module circuit. Now this process takes a while. There in the center of the screen is our vacuum chamber. After we pour the cell guard into the kit box, we'll place that down inside the vacuum chamber. And then we'll draw out the bubbles of the cell guard with the vacuum. Come on, hurry up. That's some thick stuff right there. All right, finally. That was the A part. Now, for the B part. Let's mix both components together. That should be good enough. Thoroughly mixed. The next step, let's pour it into the kit box. Try to make sure that I cover all the components with the cell guard. I don't fill it up all the way because, as you see in a little bit, when the bubbles start to draw out, the cell guard will overflow the kit box. And afterwards, we'll open up the chamber and add more cell guard. There we go. Let's place our high voltage module inside the vacuum chamber. Try not to spill it, Peepaw. Okay, I'll try not to. Okay. Turning on the vacuum pump. You can see the gauge on the vacuum chamber is increasing. A little bit more. I'm looking inside the chamber through the plexiglass lid to see if the bubbles are starting to draw out. Increasing vacuum. Okay, we'll stop right there. Now we're looking down into the chamber through the plexiglass lid. And you can see the kit box and the bubble formation on top of the cell guard. Now at this point right here, it's been about 10 minutes under vacuum. In a little bit, we'll open the release valve and you'll see the bubbles dissipate. We want to draw out as many bubbles as possible. Okay, let's just crack open the valve a little bit. You don't want to open it up all the way because depressurization will cause the cell guard to flow out of the kit box from air pressure entering the chamber. It'll squirt that cell guard out all over the place. I've done it before. I've learned from experience. So we just crack the release valve open just a little bit. Now you can see the bubbles are starting to pop. They're going to disappear here in a little bit. Then we'll open the lid and add more cell guard to the top of the cell guard that we've already poured into that kit box. Won't quite open it up yet until most of the bubbles, if not all, have popped, have dissipated. You can watch the vacuum chamber gauge when it reaches 0 psi, not psi, sorry. When it reaches 0 vacuum, then you can move the lid off of the kettle. There. Did you see that? Did you see the kettle? It wobbled. That means that the lid popped clear. That yellow seal popped clear of the kettle. Now we can remove it. Still some bubbles. Now this takes an overnight stay in the vacuum chamber for all of the bubbles to be released. Adding more cell guard to the top. You can see there on the bottom I have a piece of cardboard, and you can see where the cell guard has overflown the kit box onto that piece of cardboard. I got that piece of cardboard down there so that the cell guard doesn't accumulate on the bottom of the kettle. Going to try to pour all of that cell guard out onto the top of this kit box right here. There we go. Is that all of it? A little bit more? Come on. We ain't got all day. Hurry up. There's some tedious work right here. There we go. I think we got it all that time. Reinstalling the lid. Closing the valve to the vacuum chamber. Making sure I got the seal centered on that kettle. Okay, here we're turning on the motor here in just a little bit. Okay, you can see the bubbles starting to draw out once again. This is the whole purpose of that vacuum chamber, is to draw as many bubbles out of that cell guard as possible, and that way we won't have any air gaps in the cell guard. We'll have a good seal on that circuit. Yep, all the bubbles once again being drawn out. Once they get to the surface and we release pressure on the chamber, they'll pop. And when we leave it under vacuum overnight, that cell guard will be cured and it will be as clear as glass. It's an amazing product. It's really good for this high voltage stuff that we're dealing with. You don't want no humidity or moisture or anything that can get into that high voltage circuit and cause it to short out. We have some fireballs in there, some lightning strikes, if we had moisture get onto that circuit. There's some big bubbles there. Look at that. Okay, cracking open the valve again. Letting more vacuum pressure out. Don't want to open up that valve too fast. There we go. There we go. Let's see what we look like now. Looks really good. Looks really nice. This is day 2. It sat overnight. Looks really nice. Sat overnight under pressure, pulled all of the bubbles out of that cell guard. It's amazing, you can still see the circuit down inside that kit box. It doesn't even look like it's sealed up. You see the little P label I've got on that one capacitor there? That indicates to me that this is the positive high voltage module. When I build a negative high voltage module, I put an N on that capacitor. There we go. Now I've installed the high voltage module onto the positive power board, and we are going to test that high voltage module to make sure it works. As much as I can, I try to test the circuits that I construct or repair. Sometimes you can't. Sometimes you just have to hope and pray that your repair or your construction works, especially with like servo drives when you don't have the motor or the feedback cable. You're not able to test the drive that you repair, but you can at least power it up. And if it don't go bang, that's like 50% of it. It's probably okay. Your repair's probably worked. Your repair's probably been good. Okay, now I'm going to unplug the Chargemaster so that when I install this metal rod into the output of that high voltage module, I won't get lit up. There we go. Now the purpose of that rod is so that I can probe the output of that high voltage module with a high voltage probe attached to my Fluke oscilloscope. And what we have to do here, I'm installing a jumper on these 2 terminals, and this is the enable. This will enable the output of the Chargemaster, that high voltage output. You have to jump these 2 terminals together. It's like an on-off switch. There we go. This is our high voltage probe. That is attached to our Fluke DMM. Attach the black lead to frame ground. Let's turn on our meter. Now the probe here is 1000 to 1. So when we see 1 volt on the meter, we will have 1000 volts on that metal tip. We're going to touch the metal tip to the probe. Peepaw! You gotta plug it back in. It won't power up without the plug. Okay. There we go. Now it'll power up. Okay. Don't touch that rod with your hand, people. There we go. Increasing the voltage with the potentiometer. There's 5,100 volts DC. There's 9,980 volts DC on that rod. That's the output of the high voltage power module. And you see we're positive. We don't have a negative sign in the display of our meter. Let's go up just a little bit. There we are. 10,180 volts DC. Shoo-wee. And this Chargemaster will go up to 30,000 volts DC on the positive side and negative 30,000 volts on the negative side. Okay, I've turned the power down. There's no output of the high voltage module. There we go. Okay, we unplugged the Chargemaster from the wall. And we're going to move the metal rod from the output of the high voltage module. When working with high voltage right here, I always try to, if I can, unplug that Chargemaster from the wall just to ensure that it is positively turned off. Now we're going to look at the front of the Chargemaster. That right there is the check system on the positive side. I don't have the negative side installed yet, so when that neon light is on, the Chargemaster is set to 0 volts. Now, if we tried to increase the voltage and that neon stayed on and the gauge did not increase, that means that we would have a problem. And that's what we had when we tried to increase the voltage. It did not go above 0, and that check system positive neon did not turn off. Now you can see in the gauge for the positive side, I've increased it to 10,000 volts DC. There you go. That's a nice working high voltage module. Good job, folks. You fixed another one. Let's get on out of here.